Yes, welcome back to our online class. We will still be taking ordinary differential equation and we're taking some problems, but this time around we're going to be solving problems using the linear differential or forming making the equation to become a linear differential equation so that we can be able to have a solution, a general solution. Now, we have problems here. Number 1 over x divided by x minus 2y over x squared equals x cosine of x. And the question number 2, 1 plus x squared, into bracket, multiply the y, the x minus tan x plus y equals to 0. So let's get started. Solution. Question number 1. So we have 1 over x, the y, the x, minus 2y over x squared equals x cosine of x. Now, our aim when we say linear equation is to ensure that this derivative do not have either the dependent or the independent variable as a coefficient. You can see the y dx is having a coefficient of 1 over x, so we try as much as possible to remove this. So what do we do in this case? We are going to multiply this equation by x. So let's call this equation 1. So multiply equation 1 by x. So if I multiply all through by x, we multiply 1 over x, I'm going to have the y over dx. Now minus x, we multiply 2y over x squared. I am going to have negative 2y over x. Again, x, we multiply x cosine of x, and I'm going to have x squared cosine of x. Now you can see that this has become a linear differential equation. Now we need to solve this. This is different from the separable method. In this case, you are going to get an integrating factor, and your integrating factor is the coefficient of y. So integrating factor is negative 2 over x. But how do we do that? You are going to find an exponential which you are going to integrate. Can you see that? Can you see? Very good. So that will now be equal to the exponential of, if I bring out this negative 2 outside this integration symbol, I'm going to have negative 2 integral 1 over x. Right? Now, what is integral 1 over x? You all know that is what? Ln x. So what I'm having here is equal to exponential negative 2 natural log of x. Now, I'm not going to stop here. I can also follow the law of logarithm of powers. So I'm going to have this to be equal to exponential ln of x raised to the power what? Negative 2. Now, I have gotten this integrating factor. What I do next is I use this integrating factor to multiply everything here. So I'm going to have, if I use this to multiply everything, I'm going to have, now from here, exponential ln will cancel out. So in fact, the work is done. So I have x raised to the power minus 2. So I'll use x raised to the power minus 2 to multiply everything here. Very quick. So I'm going to have x raised to the power minus 2 to multiply the y over dx, then minus x raised to the power minus 2 multiplied 2y over x. Again, x raised to the power minus 2, we multiplied, then put x squared cosine of x. Now, do you know that the value I'm having here is similar to saying the derivative d dx of the integrating factor x raised to the power minus 2 multiplied by my y. That is y x raised to power minus 2. That is what I'm having at the left hand side. If I differentiate with respect to y, I'm going to be having x raised to power minus 2 dy dx. Now, if I differentiate with respect to x raised to power minus 2, that's product rule, and I keep this one constant, I'm going to be having negative x raised to power minus 2 to y over x. Very good. So I have this side also to be what? This is 1 over x squared multiplied by x squared cosine of x. So this can cancel out this. Very good. You can see now I now have the dx of y x to the power minus 2 to be equal to what? The cosine of x. I can now integrate both sides. How do I integrate both sides? That is, the ds of this equal to cos x dx. If I cross multiply the x to this side, I hope you understand. So I have y x raised to the power minus 2 to be equal to, if I integrate cos x, I'm going to have what? Sine x. Then my plus c. So I can divide all through by x raised to the power minus 2. Because what I'm having here is y over x squared to be equal to sine x plus c. So it means I can multiply by x squared. So that I will have y to be equal to x squared into sine x plus c. And that is the answer. Can you see that? So remember to use the coefficient of your y as the integrating factor. When you solve that using the exponential to the integral of that coefficient, you get your value and use the value to multiply through the equation. What you have here is just your dependent variable multiplied by what? Multiplied by integrating factor. That is the derivative. So you integrate the dx of that, then you come to the right hand side and do your work. Now let us take the next example. Now we have number 2. We have 1 plus x squared dy dx minus tan x plus y to be equal to 0, right? Now, again, we said we want to make this to become linear. Okay, what do? You are going to divide all through by what? 1 plus x squared. But it's very good we move this to this side. Do you get now? So we're going to have 1 plus x squared dy dx plus y equals, if this cross to this side, 0 plus, that's tan x. Very good. So from here, I can divide all through by 1 plus x squared. So that we have the y dx plus y over 1 plus x squared equals tan x divided by 1 plus x squared. Now from here, again, you are going to have your integrating factor. Integrating factor IF this time around now is exponential to the integral of what? 1 over 1 plus x squared. That is what you have now. 1 over 1 plus x squared. I know this is the x. You integrate with respect to x, likewise what we did here. Thank you. So, very good. So, the x. Do you remember that if you integrate 1 over 1 plus x squared, that will give you what? Tan x. Very good. Very good. So it means that what we have here is exponential tan x. Tan x. So we will use this to multiply the whole of this equation. Now, without wasting our time, we already know that what we are going to have at the left side is our what? Dependent variable multiplied by this integrating factor. So I will just put y dx of y multiplied by exponential tan x to be equal to what? Exponential tan x also multiply this side. So tan x divided by 1 plus x squared let me put this here, multiplied by exponential arc tan x. Well, this is sorted out if I bring the integral. So I have this side to be y exponential arc tan x, and that is equal to this side. I have arc tan x over 1 plus x squared multiplied by exponential arc tan x. Thank you. Now, in order for me to be able to integrate this side, you are going to recall that if I should differentiate arc tan x, what will I get? I will get 1 over 1 plus x squared. So let me say let u be equal to arc tan x, right? So that the u dx will give me what? 1 over 1 plus x squared. Now, if I substitute, this is my dx. Now, my dx will be equal to 1 plus x squared over 1. So I'm going to substitute that for dx. So I'm going to have y exponential arc tan x to be equal to integral. I said arc tan x now is my u. So here I'm going to have u over 1 plus x squared dot exponential arc tan x again here is my u, and my dx this time around from here is what? 1 plus x squared. So this can cancel out this. So what I'm having now is y exponential arc tan x equal to integral u dot exponential u. Now from here, I'm going to integrate by part. You know, if you integrate by part, let's take this right hand side, integral u dot exponential u using our uv minus integral v du. My u is u here, and my v, if I make this dv, if I integrate, I'll still have exponential u minus integral v again, that is from here, I will have exponential u. If I differentiate, you will have 1. So I will have u exponential u. If I integrate this, I'm going to have negative exponential u. So this is what I will have if I integrate this. This is it. So I have y exponential arc tan x to be equal to u exponential u minus exponential u. So I'm going to put back the value of my u. Don't forget we said that u is arc tan x. Good. So y exponential arc tan x is equal to arc tan x exponential arc tan x minus exponential arc tan x. So I can divide all through by exponential arc tan x. So if I divide this by exponential arc tan x, I also divide this by what? Exponential arc tan x. I also divide this by exponential arc tan x. Don't forget, I was supposed to have my plus c here anyway. So my plus c. So what I will have is y is equal to, I have arc tan x now minus 1 plus c, and that is what? The answer. Very good. So remember, the deal is you must be happy, I must be happy, we must be happy. So do so well to like, comment, subscribe, and share. Thank you.